Okay, is this on? Yeah, okay. So this is probably a bad idea, but I've got about an hour before I have to go to work. I didn't change any code yesterday, but I was playing with this yesterday, and I noticed a bug, and today I want to try and fix it. So let me first recreate it. I don't exactly know a quick way to recreate it. I was trying to draw some flip-flops. So let me just draw myself a slow clock here. Oops. Oops. One more row. Oops. No, 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 no. Do I have an odd number or something? Or an even number? Oh, there we go. Okay, great. So that's our clock. Now I gotta remember how I drew those flip-flops. So I need I think I did it like this. And now I just need the clock gators. And then this one needs to have a negator for the data input. So the clock will, so the data comes in on here. And the clock comes in on here. Like that. So this is now a D latch. The D input is this. Now what I did for the D input, just to prove to myself that it was working, is I made one of these guys. I guess flashing lights warning. Okay. So, on this cycle, let me see. I can't point with the cursor when I'm on frame by frame mode. The D input is 1. The clock input is 1. So when I go to the next frame, the two gates there, so the gator gates, the clock gator gates, The top one will stay the same as it is. The bottom one will also stay the same as it is. Wait a second. Because the clock is 1, it's forcing both the SRs to 0, so I think the SRs will stay the same as they are. What about the other two gates? They should also stay the same as they are, right? Oh. So this is the bug I was talking about. So let me just go forward until the bug disappears, and then I want to see how it reappears. So basically the bug here, oh, there we go. Okay. So let me see if I can just quickly, okay. So here, this here is the SR latch, right here. And the two wires should always be opposite polarity. If they're ever the same polarity, let me see if I can show you what I mean. Oh no, this is not where that should go. So see here how if they're the same polarity, they will just toggle back and forth forever. You see, because here both gate states are 0, so on the next cycle they will force both wires to 1, which causes both gates to become 0, and you see what I mean. So it shouldn't be possible for this to happen, I think. I mean, unless I drew the circuit wrong. Okay, stop. So I want to understand how it happens, and I don't really see any other way to do it than to just go one frame at a time. There's our clock. Here's our D input. And now, again, flashing lights warning. Okay. So at some point, it actually fixes itself, because one of the SRs gets asserted. Oh man. Oh, okay. So here, here because data is 0 and the clock is this is, by the way, this is active low on the clock. So because the clock is low, meaning that the latch is active, and because data is wait a minute, 0. So on the next cycle, the S input. Okay, so wait a minute. On this cycle, the problem here is that the gates aren't combinational. It makes it a little bit harder to understand what's going on. But so on the next cycle, so let's call the gates here. Fine, and let me just do this so that I can name the gates. I wish you could put text on them, but let's call this gate here A, that one there B. So A and B are the clock gator gates, and then C and D are the latch gates, the SR latch gates. Okay, so A, B, so A, this one, B, that one, C, this one, D, that one. Okay, so let's go back into frame by frame mode, although let me try and pick a good time to do that. Okay, so on this cycle, the clock is enabled, the D input is low, so that means gate A, its internal state should go to 0, and gate B, its internal state should go to 1. By doing that, gate, the output of gate A will go to 1, the output of gate B will go to 0. Now for gate C, nothing should, wait, no. For gate C, nothing should change, right? Oh, no, I see. Gate D is going to change on this cycle, but gate C isn't. Yeah. So A, C, and D changed. And this puts us in a state where if the clock were now to get disabled, now we would have the SR latch oscillating. And now here the same thing should happen, but the other way around. Now A, B, and C should change. Oh wait, hold on, C isn't changing at all. All right, let's try something. First, let's double check that it's not because I don't remember how to draw an SR latch, so SR latch. No, not videos, images. Yeah, I mean, this is exactly what I have. Yeah, this is exactly what I have. Oh, what is this? Oh, I see. This just moves the inverter for D. Maybe this problem just isn't solvable. Or what if I try messing around with the gate for C? Because here the problem is that, oh wait, C just went to 0. And I wasn't paying attention. Oh. Okay, hold on, let me just zoom forward here. Okay, so here C gets stuck at 1. And at some point the slow clock there will turn on. I'm just trying not to miss it. C gets stuck at 1. Okay, now on this cycle the clock goes back up to 1. I think C will stay at 1. I don't think, I think I got unlucky there with the test case. Yeah, C stays at 1, but D goes to 1. And why does D go to 1? So yeah, now these two are just gonna oscillate. So how can I prevent C from getting stuck at 1? I don't know if there's a way. This isn't actually a problem, I don't think, in my simulation logic. I think it's a problem in how these circuits have to look different. What if I try using a different gate? I mean, now I'm just getting desperate here. It's unlikely this is going to fix the problem. Let's just try messing around with some other ideas before we throw in the towel. Now this isn't actually a bug, I don't think, in the simulation logic. Dude, are you hearing that? There's some godforsaken noise outside. Clearly this isn't working. Right, hold on. Let's just turn this off because it's bothering me. So if I were to raise the set input, which is this one down here, Okay, now this is a bug. What? Who's driving this net? Do we have any bad post conditions? Apparently not. Okay, now this is definitely a bug. This net right here has no drivers, and yet somehow it's connected to the clock. Oh my goodness. Okay, something has gone horribly, horribly wrong. Alright, let's... Oh my god. Where is this? Assert g.neighbor equals c. Where was that? Add all of c's gates to p and make sure the port pointers are updated. Merge previous and current. How on earth am I going to recreate this? Alright. There is something I've been meaning to do. Maybe this will help. Over here in post condition, we still have to do junctions. So let's do that. How much time do I have? Okay, I'm still doing okay for time. Now how does this work? We will do local nr equals j dot port 1. I know, let's call this PR equals j dot port 1 if PR dot so local nr is equal to pr.net if nr does not equal blank, and not nr.j of PR, then I need to do something for, I was thinking about this, but this is where I need to put the junctions. Alright, let's finish this up down here. If nr does not equal blank and not nr.j of PR. Wait, no, it should never be blank. It should never be blank. nr does not equal blank. then, so now here, now we gotta do some printing, some nice printing. So junction I, port I'll just type it in port 1. Goes to net. Oh wait, I got an extra indent on that. Local, what did I call it? Nnum. Nnum equals index of, how does I use the index of? N in nets, so I guess nr in nets goes to net nnum. I'll say but net wrong. And then we need to do the same thing for the other one, so p.dir, since I did bother to do that. Okay, so that should take care of that. Now let's go up here. Check net with junctions. Let me see, for j in pairs n dot j, oops, j do, if j.net not equal n, then local jj equals j.parent local jnum is the index of jj in junctions. Then net I points to junction jnum dot j dot dir, but junction wrong. All right. So let's just, you know, do our thing. I'll make a slower clock this time. Or a faster clock, I mean. Okay. Let's draw our little circuit again, the one that doesn't work, but you know, it's the only way I know how to recreate this issue. There's no junctions in it, so we definitely don't expect to see that post condition. Okay, so 1, 2, 3, gate, no, 1, 2, 3, gate. Ugh. Oh, whoops. Okay, let's try that again. So, alright, I'm not going to bother to go down and then all the way down there. I'll just do it over here. Whoops. Whoops. I really need an undo. Okay. So okay, let's check the post conditions. No bad post conditions. So now let's start erasing some stuff. No bad post conditions. No bad post conditions. Still no bad post conditions. Whoa. Oh yeah, I see, because that's interesting. Still no issues. Don't ask me why. Man, how did I get that bug to happen? Man, this seems like a tough one. How did that happen? Am I ever going to be able to recreate this? I'm sorry about the flashing here, but okay, what if I do some crazy stuff with the express intention of trying to Alright, I can't think of anything else I can do. So, well, let's leave these here because I don't want to place them again manually in case I want an oscillator again. So let's just go crazy with the wires and junctions. Okay, something weird I've been noticing for a few weeks now. There's a building kind of like not across the street, but like a block away. And in one of the apartments, I keep seeing these bright flashes of light. And usually, the entire apartment has the lights turned off, and then just this really bright flash happens. I don't normally notice it during the day, but I just noticed it now at the corner of my eye. And to me, it's as if somebody was taking a picture with a flash, which doesn't make sense because, like, I don't know, like, the only way I would see that flash so brightly from all the way here, like a block away, would be if they were pointing it almost exactly in my direction, or at least mostly in my direction. And I don't even know if, like, camera flashes, even those big friggin', you know, things that you mount on top of your camera, like, I don't even know if they get that bright. So yeah, I think it's strange. But anyway, where was I? Yeah, I was trying to create this situation. Whoa, oh my God. Okay, what just happened? Oh my God. What? What? Huh. What? What's in the log? Okay, let's see if we can find a smaller test case, because there's no way I'll understand this. Okay, we just have an invisible net. Net 1. 1, so 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, 6. Apparently we have 2 junctions. What? Okay, well, one thing we should do is in the post conditions here. I don't think I'm checking junction to grid, so let's do that. We can just copy this, I think. if grid of j dot parent dot c wait, how did I do that? Oh, this isn't the port object. This really is the junction object. If grid of j dot c is not equal to j, then junction I points to g dot c. Junction I points to j dot c, which has xy coordinates the following, but grid wrong. So, okay. Let's place a junction. So far so good. Put in some wires. Let's go crazy. So far so good. Let's erase some wires. Let's erase all of them. So far everything fine. Let's put in another junction and another junction. Try to wire it up. Oh my god. Oh my god. Something has gone very, 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 very wrong. I need to pay more attention here. Let's restart this. Maybe we can do it with just that 3 gate or that 3 junction case. Well, anyway, let's just see. Put down another junction. So far, so good. Put down another junction. So far, so good. Let's connect these. So far, everything fine. Let's connect these. So far, everything fine. Connect these. Everything's fine. Go crazy. Oh, wait, that's not crazy. Now, this is crazier. Still, everything's fine. Man, I don't understand. Oh! Okay. Net 3. Oh, man. Okay, it looks like maybe we can get this to happen with 2 junctions. We're slowly narrowing down the test case here. So the first thing that happens is you draw a bunch of wires. And then put in a junction. No, actually, let's try this. Let's try. First, you put in a junction, then you draw a bunch of wires, go crazy. Now, let's erase the wires. Num junctions 1, num nets 1. Okay, so far that seems fine. Just keep erasing. Num nets 1, num junctions 1. It is at 0, 1, 2, 3, 0, 1, 2, 3. Go in here and place a junction. Nets 3. Oh. There should be 4 nets. There's only 3. I need a different post condition check for this. What's the problem here? What time is it? I only have another like 15 minutes or so. All right, what if I erase the junction at 3, 5? Will we only have 1 net? Num net's 1, num junction's 1. Yeah, so this is a case of a junction pointing to itself. So I thought that could never happen, but actually it can. So that means we need to go into the nodes and uncheck this. So also there's some invariant here that I'm not monitoring for that I need to be. Oh man. Oh, how can this like wire just appear out of nowhere? Okay, here's one thing we should do. In the post conditions for the grid here, so check if u.type equals blank, that should never happen. Oh wait, we're not checking grid to junction or anything else. If v.type equals net, wait, what did this look like before? Why did I have so many conditions in here? Whoop. If v.type is net, and the coordinate is not in the net, I have no idea what this is doing. here K is a pointer to the net and v.c is a table of nets, so I really don't see what this is doing. So index of oh, just use v in nets. Grid I points to net. And get net wrong. Now another condition here is if oh, actually we'll put it here. If n num is less than 0, then grid K points to unlisted net. May as well add this in. It might spill, but and we want to do this for gates and junctions. Yeah, so, you know, this is a debug function. We really don't need to care about efficiency. So we can just copy and paste. We don't really care about cleanliness that much either. But, you know, that's the for loop. I need this. I need this. equals gate. If, oh, I have some syntax. If g.c does not equal k, then gate genum, but gate wrong. If genum is less than 0, grid k points to unlisted gate. And then we need to do the same thing again for junctions. Oh wait, what is this G? This should be V. Junctions. If not, I see I used G here, but G doesn't exist. If not V.C. Oh, wait. I just need that. And then now here, if V.C points to junction, janum, put junction wrong. If janum is less than 0, points to unlisted junction. Okay, so far so good. Only one net? Only one net shared among 2 junctions? Man, this is really messed up. So let's put in some separators in our logs. Okay. What? And still no bad post conditions? Where did this big net come from? Merge previous incur joining junction to itself. Well, we knew that. All right, I think I need even more cases here in the post condition. I think I also need to check for unlisted nets. Over here. Let me just copy this. Junction. I dot. I think I need p dot dir here. Yeah. P dot dir points to unlisted net, right? Do that for gates too. if n_num is less than 0, then gate I dot j points to unlisted net. Okay. If this doesn't catch it, I don't know what will. Okay, now we got to be real careful here. Let's put some separators in the log. Not that the log hasn't been helping lately, so maybe I need to put some more helpful messages in there, but anyway, it's good to have it when I want to add something. So, oh my goodness, okay. Junction 1, which one is that? I think I need a dumb junctions function. What time is it? Oh my goodness. I'm not late for work. I still have a half hour, but okay. So yeah, let's see if we can at least make this test case a little smaller. Maybe we can get it with even just one junction. So now this is a junction connected to itself. Okay, we found a smaller test case. We found a smaller test case. Let's see if we can make it even smaller. Okay. So that's the smallest test case I can come up with. So let me just describe it to myself. Notes. Fix me. Oops. Place fly over connect junction dot right to junction dot down, erase connection causes junction to unlisted net. Yeah, I figured. Erase connection, erase connecting wire, but not. Let's see. That is my get ready for work asshole alarm. I'll just finish up this line and then I gotta go. Yeah. Also, I don't think I remembered to change the stream title to the next number. I might have to fix that in post. Anyway, erase connecting wire, but not on a square adjacent to the junction. Okay, let's put in some separators into the logs. Now if I erase this, everything goes bad. Found neighbor. I shouldn't sit here and think about this, but anyway. DFS at 38923. So 0, 1, 2, 0, 1, 2, 3. So I erased here. It did a DFS here. DFS at 2, 3. Neighbor 2 is junction. Junction connected, keep DFSing. DFS at 2, 2. DFS at 3, 2. Okay, I need more. No, I can't do this right now. I really can't. So we will save this. We will push it to GitLab. Improve post condition check. Describe bug to fix. Ooh, Too bad. I really want to fix this right now.